Ask yourself a simple question. Where does the solar system end? Most people picture the answer instantly. That neat row of planets on the classroom wall, the sun at one edge, tiny Neptune at the other, the whole thing tidy enough to fit on a page. Hold on to that picture, because it is about to fall apart in your hands. That comfortable diagram is one of the most successful lies ever told in a science class, and it doesn't just shrink things to fit, it erases almost everything that is actually out there. The real edge of the sun's kingdom lies so far beyond Neptune that light itself takes more than a year to reach it, and we have never sent anything close. Tonight, we find the true scale of the solar system, and it is stranger, emptier, and far larger than the picture in your head. Now get yourself comfortable, hit subscribe, we begin. Let's start with why that poster had to lie in the first place. Here is the problem, and it is not a small one. You cannot draw the planets and their distances to scale on a single page. Not with clever design, not with a bigger sheet of paper. Ever. Every diagram of the solar system you have ever seen is forced to cheat, and it can only cheat in one of two ways. It can show you the planets at the right sizes relative to one another, or it can show you the right distances between them. Never both. The two truths refuse to share the same picture. Think about what that actually means. If an artist draws the sun and the planets at their correct relative sizes, the distances explode so far off the page that the next planet would sit in another room, then another building, then another town. But if the artist draws the distances correctly instead, the planets shrink until they vanish. Dots too small for the human eye to find. So every poster quietly makes a bargain. It shrinks the distances, fattens the planets, and hands you a cozy little family portrait that never existed. We all agreed to believe it, because the alternative was a blank page with almost nothing on it. And that blank page, it turns out, is closer to the truth. To understand why, you have to understand where the material of the solar system actually is, and almost all of it is in one place. The sun contains 99.86% of all the mass in the solar system. Let that number settle, because it is easy to read and almost impossible to feel. Picture the entire solar system as a single bank account holding $1,000. The sun owns 999 of those dollars. Everything else, every planet, every moon, every asteroid, every comet, all of it combined is left to split the last single dollar between them. The 8 planets you memorized as a child are the loose change, and that loose change is not shared evenly either. Nearly all of it is Jupiter. It would take roughly 1,047 Jupiters lined up and packed together just to equal the mass of the sun. Add Saturn to Jupiter, and you have accounted for almost everything that isn't the sun. The 4 rocky worlds, Mercury, Venus, Mars, and the Earth beneath your feet, are what remains after that. Our entire planet, the whole stage of human history, comes to about 0.3/10,000% of the solar system. If the planets are a rounding error against the sun, then the Earth is a rounding error against Jupiter. So the sun is not really the center of a crowd. It is a lone giant with a scattering of crumbs orbiting in enormous emptiness around it. But mass is only the first way the truth hides from us. The second way is time. Sunlight is not instant. We say it as if it were obvious, and then we forget what it means. Light leaving the surface of the sun takes 8 minutes and 20 seconds to cross the gap and reach your eyes. So the light landing on the back of your hand at this exact moment did not leave the sun now. It left more than 8 minutes ago while you were doing something else entirely, and it has been racing toward you across 93 million miles, about 150 million kilometers, ever since. You never actually see the sun. You see the sun as it was, a portrait, always 8 minutes old. Here is the unsettling part. If the sun simply vanished, if it blinked out of existence in an instant, You would not know. Not for 8 more minutes. The sky would stay bright. The warmth would stay on your skin. The Earth would keep curving through its orbit as if nothing had happened, held by a star that was already gone. For 8 minutes and 20 seconds, we would live inside a comforting lie, because the news of the sun's death would still be on its way. We live permanently inside the past of our own star, and that delay never goes away. It only grows, because the sun's light does not stop at Earth. It keeps going out to the far planets, and the gap it must cross gets monstrous. That same sunbeam, still travelling at the fastest speed the universe allows, needs more than 4 hours to reach Neptune, the outermost major planet, around 2.8 billion miles out, roughly 4.5 billion kilometres. 4 hours for light. The same light that crosses to Earth in the time it takes to boil an egg spends an entire afternoon crawling to the edge of the planets. Send a command to a spacecraft out there and it leaves your antenna. It races across the void. Hours pass. It finally arrives. Then the reply has to make the whole journey back. A single question and answer becomes most of a day. The system is drowning in delay, and we have not even left the planets yet. So how do you picture emptiness this total? You shrink it until it fits in one image. Imagine the sun reduced to the size of a basketball, sitting on the ground in front of you. At that scale, the Earth is not a ball at all. It's a grain, a tiny pellet, barely a couple of millimeters across, and it sits about 26 meters away. That's roughly 85 feet, most of the length of a basketball court, between the ball and that near invisible speck. Now walk outward. Keep the same shrinking. Where is Neptune, the last big planet? It's another grain, and it lies most of a kilometer from the basketball, close to half a mile of empty ground between the sun and the outer edge of the planets, with almost nothing in all that space but a few scattered specks you would need to hunt for. For a moment, imagine you are standing there, next to that basketball sun, and someone tells you the Earth is also in this model. You would turn in a slow circle and see nothing. You would have to walk almost the length of a basketball court, searching the dirt, just to find the pinhead that holds everything you have ever known. That is not a trick of the diagram. That is the real proportion of our home. And if a basketball on a court still feels like a thought experiment, something you can wave away, consider what happened when a handful of people set out to build the real thing. Full size, in the open world, with nothing shrunk that didn't have to be. In 2015, 2 filmmakers named Wiley Overstreet and Alex Gorosh drove out to the Black Rock Desert in Nevada, a vast, cracked, perfectly flat dry lake bed, carrying a single stubborn idea. They wanted to lay out the entire solar system to scale, with the distances honest and the proportions true, starting from an Earth no bigger than a marble. And to keep that one marble truthful, the model they had to trace stretched 7 miles across, about 11 kilometers of empty desert, just to hold the orbit of Neptune around a single blue marble. At the center, the sun was a glowing sphere the size of a weather balloon. Jupiter was the marble's larger cousin, no wider than a small melon. Everything else was beads and grains scattered across miles of dust. They camped out there for 36 hours, driving in enormous circles through the dark, tracing each planet's orbit into the lake bed with the headlights of their car. 8 faint rings carved into an empty desert floor. And at dawn, they did something quietly perfect. They stood at the spot where their marble Earth would sit, and they looked back at the little sphere they had chosen for the sun. It lined up exactly with the real sun rising over the mountains behind it, the same size in the sky, to the eye, precisely as it should be. The scale was true. Nothing had been cheated, and that whole 11-kilometer model, miles of nothing wrapped around a marble, still only captured the 8 planets. It ended at the orbit of Neptune, at the exact place your childhood poster ends. And the real solar system does not end there. It does not end anywhere close to there. So how far does it truly reach? To feel that honestly, we have to bring in the fastest machines our species has ever built, and then watch them lose to the distance. Here's a question worth holding for just a moment before the answer arrives. In almost 50 years of flying outward without stopping, never slowing, never turning, how far do you imagine our most distant spacecraft has actually gotten? Fix a guess in your mind. The craft is called Voyager 1. It launched in 1977, and it has been coasting outward ever since for 48 years without a single pause. Today, it sits more than 15 billion miles from home, over 25 billion kilometers, so remote that its faint radio signal, moving at the speed of light, now takes almost a full day just to reach us. 48 years of flight, the farthest and longest travelled object human hands have ever made. And it still has not crossed the true edge of the solar system. It is not close. It has barely begun. Then there is raw speed. A NASA spacecraft called the Parker Solar Probe holds the record for the fastest object human beings have ever built. Diving in close around the Sun, it reached 692,000 kilometers per hour, about 430,000 miles per hour. At that pace, you could cross from Washington, D.C. to Tokyo in under a minute. You could circle the whole of the Earth in roughly 3.5 minutes. Nothing our species has ever set in motion has moved faster. And here is the number that should quietly stop you where you sit. That speed, our fastest ever, the crown of every rocket we have ever flown, is just 0.064% of the speed of light. Not 6%, not 1, 64 thousandths of a single percent. Light covers the very same ground more than 1,500 times faster. And light, remember, already needs more than 4 hours simply to reach Neptune. Point that record-breaking probe toward the nearest star instead, and it would need more than 6,000 years to arrive, longer than the whole of recorded human history, laid end to end. A crawl. Against distances like these, the fastest thing we have ever built is very nearly standing still. The barrier out here was never our speed. It was always time. So let's come back one final time to that poster on the wall, now that we can see plainly what it did to us. The 8 planets you learned as a child, Mercury out to Neptune, are not the solar system. They are a thin, warm, bright smear of worlds, huddled in close around the Sun, the inner core and nothing more. Past the last of them, the map simply goes dark, because almost no one is ever taught what waits inside that dark. Beyond Neptune lies a frozen ring of icy worlds most people never learn exists at all. And beyond that lies something stranger still, a vast, faint shell of frozen bodies wrapped the whole way around the Sun, reaching so far outward that it stretches nearly halfway to the next star. Names most of us were never handed, but should have been: the Kuiper Belt, Sedna, the Heliopause, the Oort Cloud, and none of this is a guess. Every distance, every boundary we are about to cross has been measured, tracked, and confirmed by real spacecraft that flew there and real telescopes that watched. This is not imagination. This is the honest map, redrawn at last. The solar system was never a tidy little row of planets. It is a single island of light, adrift in an ocean of dark. And if that comfortable poster fooled you for years, take some small comfort in this. It was built to fool you, and it fooled very nearly everyone. But here is where the ground opens beneath the entire question. Ask a room full of scientists where exactly the solar system ends, and you will not get one answer. You will get 2, and they disagree with each other by an almost unimaginable distance. One edge sits where the Sun's wind finally dies away into nothing. The other sits where the Sun's gravity finally loosens its grip, 1,000 times farther out than the first. By the first measure, our two most distant spacecraft have already slipped across the line into interstellar space. By the second, they have barely rolled to the end of the driveway. And somewhere inside that enormous, dark, half-charted gulf, there may be something we have never once seen with our own eyes. A planet larger than the Earth, circling the Sun so far away that it has stayed hidden from every instrument we own this entire time. Which means the true size of our own home is still, at this very moment, an open question. We do not fully know how far we reach, so we are going to find out, carefully, in order, from the inside out. We begin where everything begins, at the Sun itself, and we move outward one world at a time until we reach the freezing dark between the stars. And the very first step, the short, familiar hop from here to our own star, the step that feels safest and smallest of all, is about to take your sense of scale and quietly break it in half. So we take that first step. We go all the way in to the Sun itself, and we stand at the only true starting line this journey has. Up close, the Sun is not the small yellow coin it pretends to be in our sky. It is a churning ball of fire nearly 1.4 million kilometers across, about 864,000 miles. Line up our own planet edge to edge across the width of it, and you would need about 109 Earths just to reach from one side to the other. But even that barely touches it. Numbers this size slide straight off the mind, so hold one image instead. If the Sun were a hollow shell, and you could pour whole planet Earths into it like marbles into a jar, you would need roughly 1.3 million of them to fill it. Not 100, not 1,000. 1.3 million Earths poured into a single star. That is the object we are standing beside as we begin. And the very first step away from it, the short step back toward our own planet, is the one that quietly breaks the mind. Here is why. The distance from the Sun out to the Earth is so large, and it comes up so constantly in this story, that astronomers stopped trying to write it in ordinary numbers and turned it into a ruler instead. That one gap, Sun to Earth, runs about 149.6 million kilometers, or 93 million miles. They took that exact distance, drew a line around it, and gave it a name. 1 astronomical unit. 1 AU. From this moment on, that single step becomes our yardstick for everything that follows. Every planet, every boundary, every frozen world out ahead will be measured by how many of these Earth to Sun lengths it lies from the fire. It is the one honest ruler for a place too big to picture. So how far is just one of them really? Forget rockets for a moment and picture something you know in your bones, a car on an open highway. Imagine you could turn your car straight up out of the sky and drive off toward the Sun, holding a steady 60 miles an hour, the speed you would take on any freeway, and never once stopping. How long is that drive? About 177 years. You would be born, grow old, and die behind the wheel. Your children would take over, grow old, and die. Their children too. 3 full human lifetimes of unbroken driving, day and night, for nearly 2 centuries, just across the first single rung of this ladder. That is 1 astronomical unit. Hold that number close, because everything out here is measured in it. And this is where that first step stops being only a distance and becomes something far stranger, because that same 1 astronomical unit is also a measure of time. We brushed against it at the very start of all this. The light from the Sun takes 8 minutes and 20 seconds to reach us, which means 1 AU is not only 93 million miles, it is also 8 1/3 minutes of light. Out here, distance and time quietly melt into the same thing. To ask how far away something is becomes the very same question as how long ago you're seeing it. That can sound like a poetic little detail. It is actually one of the hardest walls we have ever run into. Because light and radio both travel at exactly the same speed, we can never, anywhere past the Earth, speak to our machines in real time. Think of the small, maddening lag on a bad video call, that half second where two people keep stepping on each other's words. Now stretch that lag from half a second out to more than 8 minutes, each way. You could not hold a conversation across a gap like that. You could only send a message, and then sit and wait a quarter of an hour for the answer to come crawling back. And you could certainly never steer anything in real time. By the moment a warning reached you, and your correction raced all the way back out to the machine, 17 minutes would have gone by, and whatever you were trying to prevent would already be ancient history. This is not a thought experiment. It is exactly why the rovers we land on Mars cannot be driven like remote-control cars from a desk on Earth. A single command can take anywhere from 3 to 22 minutes just to arrive, and as long again to answer, so the machines have to feel their own way across the ground, spotting rocks and cliffs and steering around them entirely on their own. We do not fly our spacecraft out here. We write them careful notes, send those notes into the future, and hope. Now, with that ruler in hand, we can walk outward and meet the worlds huddled nearest the Sun. Mercury circles closest, at about 0.39 astronomical units, some 58 million kilometers out, or 36 million miles. Venus comes next, near 0.72 units, roughly 108 million kilometers, 67 million miles. And then our own Earth, at 1 unit exactly, with Mars just beyond it at about 1.5, around 228 million kilometers from the Sun, or 142 million miles. We call these four the inner planets, the warm and rocky heart of the map, the crowded part. But that word, crowded, is about to come apart in your hands, because even here, packed as tightly together as planets ever get, these worlds are separated by tens of millions of miles of pure nothing. To feel how empty it truly is, shrink the whole thing down to something you could hold in your own face. Picture the Sun reduced to the size of your head. At that very same scale, the Earth is not a ball you could cup in your hands. It is the size of the pupil of your eye, a tiny dark point, and nothing more. That is the honest ratio between our world and our star. Now let that head-sized Sun become a single 8-inch ball, about the size of a bowling ball, and set it down at one end of a long, open field. We are going to walk the inner planets out to scale, one at a time. 10 paces from the ball, you crouch and set down a pinhead. That pinhead is Mercury, the entire planet, a scorched, sun-blasted world, and already at just 10 paces it looks utterly lost beside the ball, a fleck you could lose in the grass. 9 more paces, and you lay down a single peppercorn. That is Venus. 7 more paces beyond that, 1 more peppercorn, and there is the Earth, every ocean, every mountain range, every life that has ever drawn a breath, all of it in a peppercorn, 26 paces from the ball. And right here, standing on the spot, you can prove the scale is honest. Turn and look back at the bowling ball Sun from your peppercorn Earth, and it appears exactly the same size in your view as the real Sun does in the real sky. The model is not cheating. This is genuinely true. 14 more paces and you drop a second pinhead. That is Mars, the last of the inner worlds, already 40 paces out from the ball. Walk that field yourself, and one thing lands in your body that no diagram on a wall ever could. The planets are almost nothing. The walking is everything, almost all of it, the whole model, and the whole real solar system it stands for, is simply the empty space in between. And the poster hides one last thing inside that tidy little row, the row itself. Every diagram lines the planets up single file, as though they politely queue along one side of the Sun. They never do. Picture instead a handful of runners, each jogging around their own circular track, one track set inside the next. Sometimes two runners pass close by on the same side of the field. Sometimes they are stranded at exact opposite ends of the stadium, as far apart as the whole arena will allow. The distance between any two planets is not a fixed number at all. It is forever breathing in and out. Take Earth and Mars. When the two swing to the same side of the Sun and line up just right, they can close to within about 55 million kilometers of each other, 34 million miles. And even that, their closest possible approach, the very best case there is still more than 100 times the distance from here to the Moon. But when they sit on opposite sides of the Sun, that very same pair is flung apart to nearly 400 million kilometers, around 250 million miles. The same two worlds, more than 7 times farther apart, depending on nothing but the day you happen to look. And this is no trivial point either. It is exactly why we cannot simply fly to Mars whenever we please. The favourable moment when the two worlds swing close enough for a crossing comes around only about once every 26 months. Miss that narrow window, and you wait more than 2 years for the next one to open. The classroom poster froze a single lucky instant. It quietly erased all the others, and in every one of those arrangements, the thing lying between the planets is the same. Emptiness. Very nearly perfect emptiness. A vacuum so clean that the faint scatter of dust drifting through it may as well not be there at all. We are a single warm speck, adrift in an enormous dark, and that emptiness is not merely a backdrop. It is the entire reason the Sun rules us at all. Think of one candle burning in a vast pitch-black hall. Every eye in the room turns to it, not because the little flame is blinding, but because there is nothing else in all that darkness to look toward. The Sun holds the Earth in precisely the same way. Its grip on us, from 93 million miles off, is actually rather gentle. If some other heavy body, even a modest world of rock, were to drift through the space between us and the Sun, its nearby pull could overwhelm the Sun's distant hold completely and quietly tear us loose from the only orbit we have ever known. The single reason that never happens, the only reason the Sun reigns over us unchallenged, is that the space around us is so staggeringly empty that nothing else ever gets close enough to compete. Our star does not rule by force. It rules because it is the only voice in an empty room. There is one more thing about our exact place in that emptiness, and it is the part that should make you go quiet. The Earth sits inside a narrow ring of survivable distance from the Sun, a band scientists call the habitable zone, or the Goldilocks zone, the region where a world is neither so hot that its water boils away, nor so cold that its water freezes solid. Not too near, not too far, and that band is frighteningly thin. Picture a campfire on a freezing night, and picture yourself searching for the one ring of distance around it where your body feels comfortable. Lean in just a little too close, and your skin starts to burn. Edge back just a little too far, and the cold swallows you whole. That ring where you can actually bear to sit is narrow, and the Earth is threaded inside the cosmic version of it, sitting nearer the flames than to the cold dark at the edge. By careful estimates, the comfortable band reaches from only about 5% nearer the Sun than we already orbit, out to somewhere past a third farther away. And scientists still argue over exactly where that far edge should fall. But look hard at the inner number, just 5%. Nudge the Earth only that fraction closer to the fire, and the added heat would begin lifting our oceans into the sky as vapor, and that vapor traps still more heat, which lifts still more water, which traps still more, until the seas boil away completely, and the whole planet locks into a furnace. We know exactly how that story ends, because we can see it from here. It ends as Venus, the very next world inward, a planet nearly Earth's twin in size, its surface now hot enough to melt lead, and drift too far the other way, out past the cold edge, and you reach the frozen rust and silence of Mars. We are balanced between those two dead worlds, on a sliver of just right, far finer than anyone raised on that comfortable poster would ever dream. So let's be honest about where we actually stand at this moment. Everything we have crossed to reach this point, the sun, the ruler, the four inner worlds, the razor-thin ring that keeps us alive, is the warm part, the close part, the easy part, and it has already shattered every instinct you carried in with you. Yet we have not passed a single gas giant, not one ring, not one icy moon, not one frozen world. We are still standing on Mars, the last warm rock, the outer wall of that tiny lit core, and the true solar system has barely even begun, because from here on the map changes the very shape of its cruelty. The gaps between the worlds stop adding themselves one unit at a time and start to multiply. Very soon we will stop counting in single astronomical units and begin counting in tens of them, and then hundreds. So hold that one small number, 1 AU, the step from here to the sun, the 177-year drive, and carry it out into the dark with you. You are going to need it, because the next thing waiting for us beyond Mars is the first of the giants, and the emptiness that separates us from it is larger than everything we have crossed so far, combined. So we turn our backs on Mars, the last of the warm inner worlds, and we push outward into the widening dark, toward that first giant, the world heavy enough to outweigh all the others combined. But before we can reach it, we have to cross the one stretch of the solar system that nearly everyone believes is deadly. You know the place already, even if you have never once heard its proper name. A dense field of tumbling boulders, a wall of stone standing guard between the inner planets and the outer ones. In the movies, a ship plunges in, and the pilot hauls the controls left and right, dodging mountains of rock that fill the whole screen, always one small mistake away from being crushed to dust. We have all seen it 100 times, and almost everything about that picture is a lie. The asteroid belt is a broad ring of rocky debris that circles the Sun in the gap between Mars and Jupiter, running from about 2.1 to 3.2 astronomical units out. In plane distance, that is a zone stretching from roughly 310 million kilometers to 480 million kilometers from the Sun, somewhere between 195 and 300 million miles. And yes, a great many objects drift inside it. Our best estimates run well into the millions. But here is the part the movies never tell you. Those millions of rocks are scattered through a volume so unimaginably vast that they are almost never anywhere near one another. Sit with the numbers, because the numbers are the entire story. On average, the distance between one asteroid and the next is somewhere around 966,000 kilometers, about 600,000 miles. That figure is nearly impossible to feel until you anchor it to something you already know in your body. Our own moon orbits the Earth at about 384,000 kilometers away, so the typical gap between two neighboring asteroids is more than 2.5 times the entire distance from the Earth to the Moon. The same crossing that took the Apollo astronauts 3 full days of flight to make. That is the emptiness sitting between one ordinary rock and its nearest companion. Now go and stand on one of them. Plant your feet on the surface of a single asteroid and turn slowly, scanning the sky for the next one. You would find nothing. No looming boulders hanging overhead, no crowded field of stone drifting past. The nearest asteroid would in almost every case be so far away that you could not see it at all without a telescope. A faint fleck of light, if you could pick it out, lost among the ordinary stars behind it. This is not a theory or a guess. It is something we have tested with our own machines, over and over again. Every probe humanity has ever flung toward the outer solar system, the two pioneers, both Voyagers, Galileo, Dawn, and the Lucy mission still weaving among these rocks today, every single one of them flew directly through the belt. Not one was ever in any real danger of striking a thing. The navigators did not have to swerve, they did not have to thread a path between hazards. They simply passed through, because for all practical purposes, the belt is open, empty space. But the emptiness is only half of what makes this place so extraordinary. The other half is how little there truly is here at all. Take every asteroid in the entire belt, every one of those millions of bodies from the very largest down to the smallest tumbling boulder, and imagine crushing them all together into a single sphere. You would not get a new planet. You would not even get a decent-sized moon. The total mass of the whole asteroid belt comes to only about 3% of the mass of our own moon. Everything in that immense ring gathered together would make a ball less than a fifth as heavy as tiny, distant Pluto. And even that meager total is not shared out evenly. More than half of it hides inside just 4 bodies: Ceres, Vesta, Pallas, and Hygeia, with the dwarf planet Ceres alone holding close to 40% of everything in the belt. The millions of remaining rocks are left to split the scraps between them. So, a question rises almost on its own. If there is a ring of perfectly good leftover building material sitting right here, in a stable orbit between 2 planets, why did it never gather itself into a world of its own? Why rubble and not a planet? The answer is the giant we have not yet reached. Jupiter is so overwhelmingly massive that its gravity reaches all the way back across that gap and refuses to let this region ever settle down. Picture pushing a child on a swing. If you time your pushes just right, giving one small shove at the same moment on every pass, the swing climbs higher and higher with each one. Jupiter does exactly that to the asteroids. Its gravity tugs on them at precise, repeating intervals, and those rhythmic pulls build and build until the rocks are thrown onto crossing paths and violent collisions, instead of drifting gently together. Entire lanes of the belt have been swept utterly clean at the exact distances where Jupiter's rhythm beats the hardest. We even have a name for those bare tracks, the Kirkwood Gaps, bands of near total emptiness carved out by nothing but the pull of a faraway world. So the belt is not the wreckage of a planet that shattered, the way people once believed. The truth is quieter and somehow sadder. It is a planet that was never allowed to be born, the raw ingredients of a world held apart for 4.5 billion years by the gravity of the giant next door. And that giant is exactly where we go next. Jupiter orbits at roughly 5.2 astronomical units from the Sun, about 778 million kilometers out, or 484 million miles. To feel a distance like that, follow the sunlight. The light that warms your face on Earth makes the crossing in a little over 8 minutes. That very same light, racing outward at the fastest speed the universe permits, now needs about 43 minutes to reach Jupiter. The sunlight glinting off its swirling cloud tops at this exact moment left the Sun the better part of an hour ago. And Jupiter is not merely large, it is the outright ruler of everything that circles our star. It is so enormous that more than 1,000 Earths could be poured inside it and still leave room to spare. But its true dominance lies in sheer mass. Gather up every other planet in the entire solar system: Saturn, Neptune, Uranus, Earth, Mars, Venus, Mercury, every ring and every last moon, and weigh them all together on one side of a scale. Then weigh Jupiter alone on the other. Jupiter wins, and not by a narrow margin. It is 2.5 times more massive than all the other planets in the solar system combined. Here is the most astonishing thing that follows from that. When we say the planets orbit the Sun, we picture the Sun sitting perfectly still at the centre, while everything else wheels around it. But that is not quite the truth. the Sun and Jupiter actually orbit their shared point of balance, and Jupiter is so heavy that this balance point does not sit inside the Sun at all. It floats just above the Sun's surface, which means that Jupiter, from hundreds of millions of miles away, is massive enough to make our entire star trace a small, slow wobble through space. And yet, as staggering as Jupiter is, its size is still not the real shock waiting for us in this part of the journey. The real shock is the emptiness that opens up beyond it. This is the thing the neat little diagrams hide most completely of all. As we travel outward from Jupiter, the gaps between the planets do not simply grow larger in some gentle, orderly way. They erupt. Saturn, the ringed giant, orbits at about 9.5 astronomical units, nearly twice as far from the Sun as Jupiter. Beyond Saturn, Uranus sits at 19, and beyond Uranus, Neptune at 30. Now watch how the spacing swells with each single step. The gap between Mercury and Venus, back in the crowded inner system, is only about 1/3 of 1 astronomical unit. The gap between Uranus and Neptune is more than 10 times the entire distance from the Earth to the Sun, poured into the space between just 2 neighbouring worlds. Each of these outer gulfs, the void separating one giant from the next, is larger than the whole inner solar system we have already crossed. These planets are not neighbours. They never were. Each giant sits utterly alone, a single island of gas and ice, marooned in its own enormous ocean of freezing dark. From the cloud tops of one, the next would be nothing more than a faint point of light, no different from any other star in the sky. The warm, tidy family of worlds from the classroom poster simply does not exist. What exists instead is a scattering of distant, solitary islands, separated by moats so wide the human mind can barely hold them. And at the farthest of those islands waits Neptune. Neptune circles the Sun about 30 times farther out than we do, roughly 4.5 billion kilometres, or 2.8 billion miles. Out here, the light that reaches Earth in 8 minutes takes more than 4 hours to arrive. Imagine standing on a world at that distance and lifting your eyes toward the Sun. You would not find the broad, golden disk we know so well from home. You would see a single, blinding point of light, still searingly bright, but shrunk to little more than a brilliant star, throwing shadows that fall thin and hard and strange across the ground. The sunlight landing on you would be only about 1,000th of what bathes the Earth, and yet, this is the part that surprises almost everyone. Even that thin trickle of light is still hundreds of times brighter than a full moon on a clear night back home. So it is not darkness that rules at Neptune. It is a permanent, deep, silver twilight, presided over by one hard diamond of a sun, burning coldly at the centre of a black and silent sky. And through that endless twilight, Neptune moves with an almost unbearable slowness. A single orbit, 1 Neptunian year, takes about 165 Earth years to complete. Think about what that means against a human life. A person born on Neptune would never live to see even a single birthday. Not one full year would finish across the longest human lifetime imaginable. We first discovered Neptune in 1846, and it did not complete one single lap of the Sun from that moment until the year 2011, finishing its very first orbit since the day human eyes first found it, more than a century and a half later. Distances like these are not merely facts to be memorized. They are barriers we still cannot overcome. Only a single spacecraft in all of human history has ever visited Neptune, and simply reaching it consumed the better part of an entire generation. Voyager 2 launched from Earth in 1977, and it did not sweep past Neptune until August of 1989. 12 years of unbroken flight, running at more than 60,000 kilometers an hour the whole way. 12 years. An entire childhood. spent crossing the emptiness just to reach the final planet. Let yourself sit inside that night for a moment. At NASA's Jet Propulsion Laboratory in California, scientists pressed together shoulder to shoulder around their screens waiting, because every fresh image from Neptune took more than 4 hours simply to cross the void back home. And when the pictures finally arrived, revealing a deep blue world no human being had ever seen up close, they stood together and celebrated, Carl Sagan among them, witnessing a first that has never once been repeated. Because after Voyager 2 flew onward into the dark, no spacecraft has ever returned. Not once in all the long decades since. And that is the quiet, sobering truth this stretch of the journey leaves us holding. Our fastest, most triumphant deep space probe needed 12 full years just to reach Neptune. And it carried no people, no food, no water, and no way to ever come home. Sending living human beings out to stand beneath these distant, feeble suns is not a challenge measured in years or even in decades. It is measured in generations. The gulfs are simply, brutally too wide. So we arrive at the place that nearly every textbook, every poster, every classroom on Earth quietly marks down as the finish line. Neptune at 30 astronomical units, the 8th planet, the last of the giants, the outer wall of the solar system. Except it isn't, not even close. 30 astronomical units is nowhere near the true boundary of the sun's realm. Everything we have crossed so far, the inner worlds, the empty belt, the 4 lonely giants, the entire enormous span all the way out to Neptune, turns out to be only the small, warm, brightly lit core of something vastly, almost incomprehensibly larger. The planets were never the solar system. They were only ever the part of it close enough to the fire to be seen. Because beyond Neptune, the last of the sunlight thins away toward nothing, the cold sharpens toward the absolute, and a new frontier begins. A frozen ring of countless worlds we did not even know was there until recently, spread across a stretch of space so wide that it makes everything you have just witnessed feel small. What waits past the final planet does not simply add a little more distance to the map, it shatters the meaning of the words themselves. And the instant we cross the orbit of Neptune, the light behind us dies away, the true darkness opens up ahead, and the real journey, the one almost no one alive is ever told about, is finally about to begin. So we cross it. We slip over the orbit of Neptune, the line every classroom draws as the end of everything, and on the far side the map simply goes dark. No more planets, no more familiar names, just cold and distance, and a silence that has been waiting out here since the beginning. But we are not alone in that dark, because spread all the way around the sun, just past Neptune, lies an entire third zone of the solar system, a place most people are never taught exists at all. They call it the Kuiper Belt. Picture a colossal ring of frozen worlds, wrapped the whole way around the sun, beginning at Neptune's orbit around 30 astronomical units out, and stretching to roughly 50, that is, from about 4.5 billion kilometers to nearly 7.5 billion kilometers from the Sun, or 2.8 to 4.5 billion miles. Remember that empty asteroid belt we crossed between Mars and Jupiter? This is its monstrous older sibling. The Kuiper Belt is around 20 times wider than the asteroid belt, and holds something like 20 to 200 times more mass. But where the asteroids were mostly rock and metal, these are worlds of ice, frozen water, frozen methane, frozen ammonia, millions of them drifting in the dark. Hundreds of thousands of them are wider than 100 kilometers across, better than 60 miles, and a handful are genuine worlds in their own right, over 1,000 kilometers wide. This is the third great zone of the Sun's kingdom. And here is the strangest part. Until 1992, We did not even know for certain that it was there. It took two astronomers, David Jewett and Jane Liu, patiently hunting with a new kind of digital camera on a mountaintop in Hawaii to find the very first icy world out here. A faint speck they caught creeping across the stars. After that, the floodgates opened, and world after frozen world came tumbling out of the dark. And this frozen frontier is home to the most famous exile in all of astronomy, Pluto. Pluto was found long before the rest of the belt, back in 1930, by a self-taught farm boy from Kansas named Clyde Tombaugh, who had built his own telescopes by hand and hunted for months through millions of stars until he caught one tiny point of light that moved. For 76 years afterward, every schoolchild on Earth learned Pluto as the ninth planet, the little one at the far edge, the runt of the family. Then, in 2006, it was quietly stripped of that title and reclassified as a dwarf planet. Why? Because we had begun finding others out here, just like it, icy worlds of similar size, sharing the same frozen neighborhood. And one of them, a world called Eris, discovered only a year earlier by a team led by astronomer Mike Brown, turned out to be even more massive than Pluto itself. Astronomers faced a simple, uncomfortable choice: either welcome a whole crowd of new planets into the family, or admit that Pluto had never really been one. They chose the second, and yet Pluto did not change at all. It is exactly as large and exactly as fascinating as it was the day before we renamed it. Only the word we use for it changed, and it is a genuinely staggering place. Pluto orbits, on average, about 39 times farther from the Sun than we do, some 5.9 billion kilometers out, or 3.7 billion miles. Out there, sunlight takes 5.5 hours to arrive. And here is the detail that lets you actually feel a distance like that. If you stood on Pluto's frozen surface at high noon, with the Sun directly overhead, it would give you only about 1/900th of the light we get here on Earth. That is still bright, roughly 300 times brighter than our full moon. But it is not daylight. It is a deep, blue-grey twilight. In fact, there is a single moment near sunset here on Earth, just as the Sun slips below the horizon, when the light around you is exactly as bright as high noon on Pluto. Step outside at dusk tonight, and for one passing instant, you are standing in Pluto's brightest hour. And Pluto does not travel alone out there. It is locked in a slow embrace with a moon named Charon, fully half its own width, the two of them circling a point in the empty space between them, like a pair of frozen dancers. Barely a planet, some say. Almost a double world. For most of human history, Pluto was nothing but a faint dot, a smudge in the world's largest telescopes. To truly see it, we had to go there. And going there produced one of the most extraordinary journeys ever attempted. In 2006, NASA launched a piano-sized probe called New Horizons, and it left the Earth faster than any spacecraft in history. How fast? Think of the Moon. It took the Apollo astronauts roughly 3 days to reach it. New Horizons crossed the Moon's orbit in just 9 hours. 9 hours to cross a gulf that took living human beings 3 whole days. It tore away from the Earth at more than 58,000 kilometers an hour, over 36,000 miles an hour, the fastest launch our species has ever achieved. A year later, it swung past Jupiter and stole a little of the giant's momentum, using that colossal gravity like a slingshot to fling itself outward and shave 3 whole years off the trip. And now, hold that speed in your mind, because here is where the true scale of this place lands like a hammer. That record-breaking probe, the fastest thing we had ever flung off the surface of the Earth, still needed 9.5 years to reach Pluto. 9.5 years. A child just starting school when it launched was finishing high school by the time it arrived. The fastest machine ever built by human hands. Almost a full decade. just to reach the near edge of the third zone. It arrived on the 14th of July 2015, threading through the Pluto system and sweeping just 12,500 kilometers above the surface, around 7,750 miles, closer than some satellites orbit the Earth. It had crossed roughly 5 billion kilometers of empty space to skim past in a matter of hours. And in that moment, the entire mission held its breath, because at that distance, Pluto was so far away that a radio signal, traveling at the speed of light, took about 4.5 hours simply to reach the Earth. When New Horizons made its closest approach, the control room could do nothing at all but wait. The spacecraft was utterly on its own, out past the edge of everything, and the news of whether it had even survived was still 4.5 hours away, crawling home across the dark. When the signal finally came, a simple burst of data confirming the probe was alive and packed with memories, the room erupted, and what Pluto showed us stopped scientists cold. Everyone had expected a dead, cratered ball of ice, a frozen fossil, geologically finished billions of years ago. Instead, New Horizons revealed mountains of water ice thousands of meters tall, standing sharp and young against the sky. It revealed a vast, smooth, heart-shaped plain of frozen nitrogen, later named for Tombor himself, with almost no impact craters anywhere on it, a surface no more than 100 million years old, churning and flowing like glaciers even now. Something was actively resurfacing the place, erasing the scars, keeping it young, a tiny world, nearly 6 billion kilometers from the sun's warmth, with no business being anything but frozen solid, and it was alive with geology. No one had predicted that. No one. And there was one more thing aboard that spacecraft, something almost no one expected. Tucked inside New Horizons was a small canister holding an ounce of ashes, the remains of Clyde Tombor, the farm boy who had first spotted Pluto as a speck of light 85 years before, and who had died without ever seeing it as more than that. When New Horizons swept over those ice mountains, the man who discovered this world finally arrived at it. He is out there still, sailing on into the dark. Getting those pictures home was its own quiet ordeal. The spacecraft could only whisper its data back at 1 to 2 kilobits per second, a trickle slower than a dial-up modem from the 1990s. The complete treasure of the flyby, only about 6 gigabytes, the size of a single modern movie file, took more than 15 months to crawl all the way back to Earth. More than a year of listening, just to download a single day. But Pluto, remarkable as it is, turns out to be only one resident of a vast and crowded frozen city. The Kuiper Belt holds thousands of catalogued worlds, and most of the dwarf planets we know of in the entire solar system live out here in the cold. There is Eris, the massive world that unseated Pluto, so distant and so large, it was briefly hailed as the 10th planet. There is Make and Haumea, a strange world spun so fast that it has stretched itself into the shape of an egg, and Gong and others, a whole population of icy siblings scattered across billions of kilometers of darkness, nearly all of them discovered only in the last 25 years, and we are still finding them. The true map of this region is being drawn, quite literally, within our own lifetimes. After Pluto, New Horizons was still running, still healthy, still moving, so NASA aimed it at something even farther out. And on the very first day of 2019, more than 3 years beyond Pluto, it flew past a tiny object named Arakoth, about 43 astronomical units from the Sun, 6.4 billion kilometers, or 4 billion miles out, a full billion miles farther still than Pluto. It became, and it remains to this day, the most distant object any spacecraft has ever visited. And Arakoth turned out to be something precious. 2 frozen lumps, joined gently together like a deep red snowman, only about 35 kilometers long. But its real value was its age and its stillness. Out there, so impossibly far from the Sun, so far from anything that could ever disturb it. Arrokoth has simply sat, untouched, for 4.5 billion years, since the very birth of the solar system. It is not a broken shard of something older. It is one of the original pieces, a pristine fragment of the exact material that once came together to build the planets, frozen in place before the Earth itself even existed. Looking at a picture of Arrokoth is like looking at a photograph of the solar system as a newborn. And this is what the whole Kuiper Belt truly is. Not merely a ring of ice, but a frozen archive, an untouched library, holding the original chemistry of our own origins, sealed in the deep freeze for more than 4 billion years. Every one of these bodies is a page from the story of how we came to be, waiting patiently, out in the cold and the dark, for us to learn how to read it. And still, this is the part that refuses to let the mind settle. We have mapped only the very thinnest sliver of it. New Horizons drifts onward even now, well past 60 times the Earth-Sun distance, still faintly whispering its data across the void, and it has barely begun to scratch this frozen frontier. Beyond about 50 astronomical units, the classic belt starts to thin out toward what looks, at first glance, like an edge. And out here, everything is still held fast in the sun's invisible grip. Even across these unimaginable distances, its gravity reigns, utterly unchallenged, ruling over worlds it can no longer even warm. Turn around from all the way out here and look back toward home. The sun itself is now just a brilliant star among the other stars, and all of it, the 4 rocky worlds, the great gas giants, the entire warm and crowded core that we spent so long crossing, every single planet you have ever known has collapsed into one tiny point of light, lost in the black. The whole familiar solar system, the only home our species has ever had, shrunk to a single bright dot you could hide behind your thumb. You would think, surely, that this must be the end, the frozen ring at the very bottom of the map, the true border of the sun's realm. But it isn't, not even now. The Kuiper Belt is only the first frozen shell, the innermost layer of a darkness that runs far, far deeper than this. Because out past this belt, out where the sun has dwindled to nothing more than the brightest star in a freezing sky, we have started to find things we cannot explain. Worlds that come swinging in along impossible paths. Objects looping around the sun on orbits so vast, so strange, so deeply wrong, that by every rule we understand they should not exist at all. Orbits that whisper of something out there, something we have never seen, reaching silently into the dark and pulling the strings. So we follow them out, those impossible paths, the objects that come swinging in from somewhere far beyond the frozen belt, and then turn and race back out into the black. Because past the Kuiper Belt, the sun's family does not simply end, it scatters. Out here lies a shadowy population astronomers call the scattered disk and the detached objects, worlds flung onto orbits so enormous, so stretched, so wrong, that for years no one could explain how they came to be. And the strangest of them all has a name: Sedna, a frozen, reddish world, roughly 1,000 kilometers across, about 600 miles, discovered in 2003 by a team led by Mike Brown, Chad Trujillo, and David Rabinowitz. They named it after the Inuit goddess of the sea, who was said to dwell in the frozen depths of the Arctic Ocean. It was, at the time, the most distant object anyone had ever seen in the entire solar system, and its orbit broke every expectation we had. Here is the shape of Sedna's year. At its closest approach to the Sun, its perihelion, Sedna comes no nearer than about 76 astronomical units. That is already nearly 3 times farther out than Neptune, the last planet. But that is the close part. From there, It swings outward on a vast stretched loop to a farthest point of around 937 astronomical units, 19 times farther from the Sun than Pluto ever gets. And to travel that immense oval just once, a single Sedna year, takes roughly 11,400 of hours. Let that number find something real to hold on to. Sedna is drawing near its closest point now, and will reach it around the year 2075. But the last time it swung this close to the Sun, 11,400 years ago, the last great ice age was only just loosening its grip on the Earth. No human being had yet planted a field, raised a city, or written down a single word. The whole of recorded human history, from the very first farmers to this exact moment, is barely long enough for Sedna to finish one single lap around our Sun. And out there, at its farthest, Sedna is one of the loneliest places we know of anywhere. For a moment, imagine you are standing on its frozen surface, out near that distant point. Turn and look for the Sun. You would not find a disk at all. You would see a single, piercing star, the brightest star in your sky. Yes, but only about as bright as our full moon looks from here on Earth. It would give no real warmth and cast almost no shadow. The temperature around you would sit at roughly 240 degrees below zero on the Celsius scale, about 400 below in Fahrenheit, only a few degrees above the very coldest temperature that is physically possible anywhere in existence, and you would barely be moving. At that farthest point, Sedna drifts around the Sun at just over 1% of the speed the Earth travels, a slow, frozen crawl through the outer dark. But here is the part that turned Sedna from a mere curiosity into a genuine, gnawing mystery. Think back to that asteroid belt and to the Kuiper Belt, both of them shaped and flung and sculpted by the gravity of a giant planet. That is how we explain strange orbits out here. Some large world came close and threw the object onto a new path, but Sedna never comes close to anything. At its very nearest, it is still almost 3 times beyond Neptune, and it never comes one step closer than that. Nothing we know of out there is massive enough, or near enough, to have reached out, grabbed it, and slung it onto this bizarre, detached loop. Neptune could not have done it. Not one of the known planets could have done it. And yet, undeniably, something did. So what shaped Sedna's orbit? Scientists genuinely do not agree. Some still file it with the scattered disk. Others call it the first known member of the inner Oort Cloud, a vast outer realm we have never once directly seen. And the leading explanations are unsettling in their own right. Perhaps, long ago, another star drifted close to our infant Sun, and gravitationally lifted Sedna's orbit as it passed. For our Sun was not always the solitary star we see today. It was born inside a dense, crowded nursery of thousands of sibling stars, packed close together, and any one of them could have reached in and reshaped Sedna's path before that cluster slowly drifted apart. Or perhaps, and this is the possibility that has haunted astronomers ever since, something large is still out there, right now, hidden in the dark, and its gravity did the shaping. Because Sedna was not a lonely accident. The very way we found it carried a hidden implication. An orbit like Sedna's spends almost the whole of its 11,000-year lifetime too far away to be seen at all. We only caught it because we happened to look during the brief window when it swings near. Statistically, that meant Sedna simply could not be alone. There had to be dozens more Sedna-sized worlds out there, perhaps 100 or more, waiting unseen in the dark. And slowly, we began to find them. In 2012, astronomers Scott Shepard and Chad Trujillo found another detached world with a closest approach even farther out than Sedna's, around 80 astronomical units. Then came another, discovered near Halloween and nicknamed the Goblin, a tiny world on an orbit so enormous that a single lap takes it tens of thousands of years, swinging out perhaps 2,000 times the Earth-Sun distance. One by one, the most distant confirmed members of our solar system were turning up far, far past, 100 times the Earth's distance from the Sun. And then someone noticed something about all of them that simply should not have been there. Here is the mystery that cracked the whole field wide open. These distant, detached orbits, the most extreme ones, the ones that reach farthest out, are not pointing in random directions. They lean. Take the handful of most extreme objects, Sedna among them, and map their orbits out in 3 dimensions, and you find they are all tilted the same way, and all swing closest to the Sun, pointing in roughly the same direction in space, as though some invisible hand had quietly combed them into alignment. 6 of these extreme, far-flung worlds share this same strange orientation, and the odds of that happening by pure chance? Astronomers put it at roughly 1 in 14,000. It should not happen on its own. Something has to be holding them there, and crucially, these 6 objects had been found by 6 different teams using 6 different telescopes, pointed at 6 different patches of sky, which made it far harder to wave the pattern away as a simple trick of where we happened to be looking. In 2016, 2 astronomers at Caltech, Konstantin Batygin and Michael Brown, put forward a bold and startlingly specific answer. Something is out there, a real, undiscovered planet, huge and impossibly distant, its gravity slowly herding these far-flung worlds into their aligned orbits, the way a single sheepdog keeps a scattered flock all drifting in the same direction. They called it Planet 9. Their best estimates put it at somewhere between 5 and 10 times the mass of the Earth, a genuine planet, considerably larger than our own, circling hundreds of astronomical units out from the Sun, on a loop so vast it would take perhaps 10 to 20,000 years to complete a single time. And there is a quiet irony here worth pausing on. Michael Brown, one of the 2 men now hunting for a 9th planet, is the very same astronomer whose discoveries out in this frozen dark got Pluto stripped of its planethood in the first place. The man who once took the 9th planet away may now be on the verge of handing us a brand new one. But, and this matters enormously, not everyone is convinced that Planet 9 is real, and the doubt is not stubbornness. It is good science. The clustering that started all of this rests on a small number of objects, each one extraordinarily difficult to find, and critics argue that the pattern may be an illusion, not something out there in space at all, but something in us, a bias baked into where and when our telescopes happen to be pointed. When 2 large and careful surveys, one known as OSOS and the other the Dark Energy Survey, mapped their own distant objects and corrected for that bias, they reported finding no real clustering whatsoever. Personally, as one skeptical astronomer put it plainly, I'm not convinced the clustering is real at all. Batygin and Brown fired back, reanalyzing the data with the biases carefully accounted for, and maintained that the alignment still held up at better than 99% confidence. Both sides are staring at the very same faint handful of frozen dots and drawing the opposite conclusion. The honest answer, right now, tonight, is that we simply do not know. And even among those who believe something truly is out there, there is no agreement on what it is. Just recently, in 2025, a separate team at Princeton spotted a different oddity, a slight warp, a tilt in the average plane of the more distant Kuiper Belt, and proposed a second hidden world to account for it, a smaller, closer planet, somewhere between the size of Mercury and the Earth, which they named Planet Y. It might exist alongside Planet 9, or entirely instead of it. And then there is the strangest possibility of them all. A handful of physicists have suggested that the unseen mass out there might not be a planet in any ordinary sense, but a primordial black hole, a tiny relic left over from the birth of the universe itself, no larger across than a grapefruit, yet as heavy as several Earths, drifting silent and invisible at the edge of the sun's domain. Step back for a moment and consider what is actually at stake here. If Planet 9 is one day confirmed, it would be the first planet in our solar system discovered not by looking, but by pure mathematics. The first since Neptune itself, which was found in 1846, only after astronomers predicted exactly where an unseen world's gravity had to be tugging. But that history cuts both ways. Ever since Neptune, there has been a long line of predicted planets beyond it, and for more than a century, every single one of them has dissolved under closer inspection, a mirage each time. And so far, despite years of dedicated searching by some of the finest telescopes on Earth, no one has directly seen Planet 9. Not once. It remains a ghost, inferred, predicted, hunted across the sky, but never actually glimpsed. We may, at this very moment, be sharing our sun with an entire planet larger than the Earth, and simply never have laid eyes on it. But that may be about to change. High in the mountains of northern Chile, a new eye has just opened. The Vera C. Rubin Observatory, carrying the largest digital camera ever built, designed to photograph the entire visible sky every few nights, again and again, for 10 straight years. It is in effect a movie camera aimed at the whole universe, and it is expected to find thousands upon thousands of new distant objects out beyond Neptune, filling in this barely mapped frontier with a richness of detail we have never had before. Within just a few years, it should manage one of two things: either catch the faint, creeping glimmer of Planet 9 directly, pulling a true ninth planet out of the darkness for the first time in human history, or show us at last that the pattern was never really there. The answer to one of the oldest questions in astronomy may now be only a handful of years away. But notice what we have quietly been doing this entire time. We have been trying to find the edge of the sun's kingdom by chasing the farthest things that orbit it. And every single time, those objects reach farther out than we ever expected. Even Sedna, at its most distant, 937 times the Earth's distance from the sun, is still utterly bound to our star, still held fast on its invisible leash, still endlessly falling around the sun. It is nowhere near the true border, because there is another way entirely to find the edge of the sun's realm, not by the farthest thing it manages to hold, but by the farthest place its influence can still reach. And out here, in this silent and freezing dark, the sun is not truly silent at all. It is breathing, pushing a constant invisible wind outward, past the planets, past the Kuiper Belt, on into the void. And somewhere ahead of us, that breath finally runs out of strength and stops. That boundary, the real physical end of the sun's reach, is exactly where we go next. So we chase it, the sun's breath, streaming out into the dark. And to follow it, we first have to understand what it actually is. Because the sun is not the calm, silent ball it appears to be in our sky. It is boiling, and from its churning surface it flings a constant, invisible wind of charged particles, fragments of atoms torn apart by unimaginable heat, outward in every direction at once. This is the solar wind. It never stops, it never pauses, and it moves at a genuinely staggering speed. Hundreds of kilometers every second, something close to 1,000,000 miles an hour. A powerful hurricane here on Earth moves at perhaps 200 kilometers an hour. The sun's wind is thousands of times faster than that, and it blows without a single break for billions upon billions of years. You have, in fact, already seen its distant handiwork. When a gust of that wind slams into the Earth's magnetic field, it sets the northern lights glowing in the night sky. And that endless wind does something remarkable. As it races outward, it carves out an enormous bubble in the thin gas that drifts between the stars. A vast, invisible cocoon with the sun at its center, so large that it swallows all the planets, the asteroid belt, the Kuiper Belt, everything we have crossed so far. Astronomers call this bubble the heliosphere, and here is the first thing worth truly absorbing. You are inside it, right now. Everything you have ever known has spent its whole existence sealed within this single bubble of the sun's breath. It is the sun's true physical territory, the entire region of space where the sun's wind and its magnetic field win out over the cold emptiness between the stars. But a wind, even this one, cannot blow forever. At some point, far out past the planets, the sun's wind runs into resistance. It has been racing outward for billions of miles, thinning and slowing the whole way, and eventually it crashes into the faint gas of interstellar space and abruptly loses its speed, plunging from supersonic to a relative crawl, almost like a speeding car slamming into a wall of water. That first frontier has a name, the termination shock, and we have actually been there. In 2004, the Voyager 1 spacecraft, launched all the way back in 1977, crossed the termination shock at about 94 astronomical units from the Sun. That is 94 times the distance from the Earth to the Sun. Light itself, the fastest thing in all of existence, needs about 13 hours just to reach that far out. Beyond it lay a strange, churning region called the helios sheath, the thick, turbulent outer skin of the bubble, where the sun's slowed wind piles up and swirls against the pressure of the galaxy pressing in from outside. And then, farther still, comes the true wall of the bubble, the outermost boundary where the sun's wind finally completely gives up. Scientists call it the heliopause, and it sits roughly 120 astronomical units from the sun, about 11 billion miles, or 18 billion kilometers out, 4 times farther than Neptune. Here, at last, the sun's breath loses its long, slow battle. The solar wind, having travelled all that impossible distance, yields, and beyond this line, you are no longer inside space ruled by our sun. You have entered the interstellar medium, the actual material that fills the space between the stars. And in 2012, something crossed that line for the very first time. On the 25th of August 2012, Voyager 1 slipped across the heliopause and became the first object human hands had ever built to leave the sun's bubble entirely and enter interstellar space. Its twin, Voyager 2, crossed the same boundary 6 years later, on the 5th of November 2018, confirming the edge of the bubble from a second, completely separate point in the sky. But how do you even know when you have crossed an invisible wall out in the dark? For Voyager 1, the answer did not come easily. It slipped across in the summer of 2012, but the science team could not be certain for another full year. Confirmation finally arrived from the sun itself. A storm that had erupted on our star reached out across the void, struck the plasma surrounding the distant spacecraft, and made it ring like a struck bell. From the pitch of that ringing, scientists could measure the density of the gas around the probe, and it had leapt to nearly 100 times denser than the solar wind. Voyager had, in a very real sense, waded out of the sun's atmosphere and into the open ocean of the galaxy. It has even recorded the sound of that ocean, a faint, steady hum of interstellar plasma, vibrating in the darkness all around it. There was no wall to see out there, no line painted across space, no jolt or marker of any kind. The crossing was utterly silent and completely invisible, written only in the quiet arithmetic of particles, counted one by one as the suns slowly fell away and the galaxies took their place. And there is one detail here that sounds impossible. Out at that boundary, the thin interstellar plasma, the Voyagers drifted into registers at a blistering temperature, somewhere between 30,000 and 50,000 degrees. That is far hotter than the very surface of the sun itself, and yet it would not burn you. It would not even warm you. Because out there, the gas is so unbelievably thin, so close to a perfect vacuum, that although each individual particle races with ferocious energy, there are almost none of them there to actually touch you. You would not roast in that 50,000-degree wall. You would freeze solid. The heat is genuinely real, but there is simply nothing out there to carry it. And here is a humbling admission from the scientists themselves. We still do not even know the true shape of the bubble we live in. For decades, the accepted picture was a comet, a rounded nose facing the direction the sun plows through the galaxy, and a long tail streaming out behind. But newer models suggest something stranger, perhaps a shape more like a croissant, with two great lobes. We simply cannot tell from where we sit. As one physicist put it, we are like goldfish trying to measure the shape of our own bowl from the inside, and we cannot even reach the edges to look. Voyager 1 has never stopped. Right now, it drifts more than 170 astronomical units from the Sun, over 15 billion miles, more than 25 billion kilometers away, and it adds roughly 3.5 more of those Earth-to-Sun distances every single year. And this brings us to a milestone that is almost poetic. In November of 2026, Voyager 1 will become the first human-made object ever to reach a distance of 1 full light day from Earth. That means a radio command, traveling at the absolute speed limit of the universe, will take a complete 24 hours just to reach it, and then another entire day for any reply to crawl back home. As one of the mission's leaders described it, if she sends the simple words, "Good morning, Voyager," on a Monday, she will not hear the spacecraft's answer until Wednesday. A single conversation stretched across 2 days. And what makes that unbroken conversation almost unbelievable is the machine holding up its end of it. Voyager was built in the 1970s. Its 3 computers carry between them about 68 kilobytes of memory, millions of times less than the phone in your pocket, less than a single high-resolution photograph. It runs now on the last fading warmth of decaying plutonium, its power dwindling year by year, its instruments switched off one by one to conserve what little remains. Its cameras took their final photograph back in 1990, and bolted to its side is a gold-plated record, sounds and images of Earth, birdsong and greetings and music, a message in a bottle in case anything ever finds it. Nearly 50 years on, this frail, ancient traveller is still whispering its data home across that unfathomable gulf. So Voyager crossed into interstellar space, which surely means it has left the solar system, doesn't it? Here is where one of the most beautiful misunderstandings in all of science quietly comes apart in our hands. Because crossing the heliopause is not the same thing as leaving the solar system, not even close. And the reason is that scientists actually use 2 completely different definitions for where the Sun's kingdom truly ends. The first definition is the one we just crossed, the heliopause, the edge of the Sun's wind and magnetic field at about 120 astronomical units. By that measure, yes, the Voyagers have genuinely left. But there is a second definition, and it is far, far larger. It is the edge of the Sun's gravity, the farthest distance at which the Sun's gravitational pull can still hold an object in orbit around it. And that boundary reaches roughly 1,000 times farther out than the heliopause. Think of it like a lighthouse standing on an island. The light it throws is the Sun's wind. It reaches only so far into the night before it fades. But the island itself, the solid ground the lighthouse actually stands on, extends vastly farther beneath the water than that beam of light ever touches. By the edge of the wind, the Voyagers are pioneers, deep in interstellar space. By the edge of the ground beneath them, they have barely stepped off the front porch. Think for a moment about what that truly means. The Sun's magnetic reach and the Sun's gravitational reach end at 2 wildly, almost absurdly different places. One at about 120 times the Earth's distance from the Sun, the other reaching out roughly halfway to the very nearest star. So, an enormous portion of what we casually call interstellar space, the region the Voyagers are drifting through this very moment, is still, by the rule of gravity, sitting comfortably inside our own solar system. NASA itself frames it in exactly this way. The true boundary, they say, is the point where the sun's gravity finally lets go, a place far beyond the planets and even beyond the great cloud of icy worlds we have not yet reached, roughly halfway to the next star. And out in that strange in-between, the Voyagers are showing us just how divided these two edges really are. Beyond the heliopause, the galaxy's cosmic rays grow stronger around the probes, no longer shielded by the sun's protective magnetic bubble. The Voyagers now drift immersed in matter that was forged and scattered by the deaths of ancient stars millions of years ago. And the bubble they left behind is not even fixed in place. It seems to breathe. In 2020, Voyager 1 detected a sudden rise in the magnetic field around it, a hint that a surge of activity from the distant sun can actually push the whole heliopause outward, the entire bubble swelling and shrinking in time with the sun's own restless cycles. The Voyagers have already turned up the unexpected out there too. The magnetic field of interstellar space proved to be about twice as strong as anyone had predicted. One more quiet reminder of how little we truly understand about the region just past our own doorstep. Yet through all of it, the sun still owns everything. Even out here, even beyond the wall of its own wind, the sun's gravity keeps its grip on a realm that continues for 1,000 astronomical units more, and then far, far beyond even that. To feel how little distance the Voyagers have really covered, hold on to this one comparison. Voyager 1, our farthest emissary, the most distant thing our species has ever made in its entire history, is right now less than 1/5 of the way out to just the farthest point of Sedna's orbit. And Sedna, remember, is still firmly, unquestionably bound to the sun. The crossing was real. The Voyagers genuinely did leave the sun's breath behind, but they never came anywhere close to leaving the sun's kingdom. The edge of interstellar space was one of the great milestones in the whole history of exploration, and it was still not the edge, because the sun's gravitational kingdom stretches on into a distance so vast that it becomes almost impossible to hold steady in the mind, reaching out toward a boundary 1,000 times more remote than the wall the Voyagers crossed, out to where perhaps 1 trillion icy bodies still quietly circle our star, 1 to 2 full light years away. Out there, past the wind, past the cosmic rays, past everything our machines have ever touched, waits the true outer shell of the solar system, a colossal, ghostly sphere of frozen worlds wrapped entirely around the sun and everything within it. No spacecraft has ever seen it. Voyager 1 will not even begin to reach it for another 300 years, and will need 30,000 more just to pass through. To grasp how empty and enormous this outer dark truly is, consider that Voyager is not even aimed at anything at all, and yet, in roughly 40,000 years, drifting on nothing but momentum, it will happen to pass within a couple of light years of another star. That is how thinly the stars are scattered out here, and how staggeringly long these distances take to cross. So to find the real edge of the sun's realm, the actual, final boundary, we have to leave the wind behind us and travel 1,000 times farther still, out into the most distant and the least understood region of them all. So at last, we arrive. After the planets, after the frozen belt, after the scattered dark and the wall of the sun's wind, here, finally, waits the real boundary. It has a name, the Oort Cloud, and it is not a line, or a ring, or a disk, like everything we have crossed so far. It is a shell, a vast, near-perfect sphere of icy bodies, wrapped completely around the sun, and every single thing we have ever spoken of, the planets, the comets, the Voyagers, all of it, sealed inside like a seed inside an unimaginably enormous frozen fruit. Everything you have ever known, everything human beings have ever touched or seen or dreamed, sits deep within this one great sphere. This is the sun's true kingdom, and its outer wall is the actual final edge of the solar system. To even speak of how far out this shell begins, our familiar rulers start to fail. The inner edge of the Oort Cloud lies somewhere around 2,000 times the distance from the Earth to the Sun, and its outer wall may reach 100,000 times that distance, perhaps even 200,000. Numbers that size mean nothing on their own, so let the light of the sun measure it for us. Sunlight reaches your face in 8 minutes. It reaches Neptune, the last planet, in about 4 hours. But that same sunlight needs somewhere between 10 and 28 full days just to reach the inner edge of the Oort Cloud, and as long as a year and a half to reach its outer wall. Think about that. Light, the fastest thing that can ever exist, leaves the sun and travels for a year and a half before it finally passes the outermost frontier of our own solar system. The bulk of this shell sits more than 1,000 times farther out than the Kuiper Belt we crossed. We have left every ruler behind. This colossal shell is thought to come in 2 parts. The inner region, sometimes called the Hills Cloud, after the astronomer Jack Hills, who proposed it in 1981, is shaped more like a thick donut, denser, holding perhaps tens or hundreds of times more frozen bodies than the region beyond it. And then, wrapping around that, comes the outer Oort Cloud, the true sphere, a ghostly halo enclosing the sun on every side, above and below and all around. And that spherical shape is not a guess. It is the single most important clue we have, because the comets that fall inward from this region do not arrive along the flat plane of the planets, the way asteroids do. They come plunging in from every possible direction, from above, from below, from every angle in the sky, and the only thing that could scatter objects evenly across every direction like that is a sphere. The shape of the cloud is written in the paths of the comets. Now, how much is out there? The estimates are staggering. The Oort Cloud may hold 1 trillion icy objects or more, each one a mountain of frozen water and gas, drifting in the black. 1 trillion worlds. And yet, here is the strange, hollow truth of this place. It is very nearly empty. Spread that 1 trillion objects across a sphere this monstrously large, and any 2 neighbours end up separated by tens of millions of kilometres, often more. If you are standing on one of these frozen mountains, the nearest other object might be farther from you than many planets are from each other, and the total mass of everything in this immense shell, all 1 trillion pieces combined, likely comes to just a few times the mass of the Earth. That is the whole paradox of the Oort Cloud in a single thought. Trillions of objects, scattered so thinly across so much space that together they barely add up to a handful of planets. Out there, the icy bodies drift around the distant sun like slow moths circling a single porch light, glimpsed across an enormous dark garden, and they drift with a slowness that the human mind was simply never built to hold. Consider an object halfway out in this shell, at 50,000 times the Earth's distance from the Sun. How long does it take to complete one single orbit, 1 year out there? About 11 million years. Let that settle. The last time such an object was in the same spot it occupies today, there were no human beings anywhere on Earth. Our earliest ancestors had not yet even split away from the other apes. An entire orbit out there is longer than the whole existence of humanity, many times over. And it moves so slowly because at that distance the sun's grip has faded to almost nothing. The Sun's gravitational pull-out in the Oort Cloud is roughly 4 trillion times fainter than what holds you in your chair right now, this instant, keeping your feet against the floor without you ever having to think about it. These frozen worlds are bound to our star by the faintest imaginable thread, a whisper of gravity, stretched across the dark. But here is the part that should stop you. Everything I have just described, the shell, the trillion worlds, the sphere enclosing our entire solar system, no one has ever seen it. Not once, not with any telescope ever built. The Oort Cloud is to this day entirely theoretical. Its objects are so small, so dark, and so unfathomably far away that seeing them directly is far beyond us. By some estimates, we would need telescopes 100 billion times more powerful than anything we currently possess just to glimpse into it. So how do we know it is there at all? We know because of visitors. Every so often, out of that unseen shell, something falls. Let's go back to 1950 and to a Dutch astronomer named Jan Oort. For centuries, comets had puzzled everyone. Those rare, glowing visitors that swung through the sky and vanished again, sometimes not to return for thousands of years. Oort did something quietly brilliant. He gathered the orbits of these long-period comets and studied where they came from, and he noticed that again and again their farthest points trace back to the same enormous distance, tens of thousands of times beyond the Earth, and they came from every direction. From that alone, from nothing but the paths of comets, Oort reasoned that there had to be a vast invisible reservoir of icy bodies, a spherical cloud surrounding the entire solar system, quietly feeding these comets inward one at a time. He had, in effect, discovered an entire region of our solar system without ever seeing a single piece of it, and every long-period comet that has blazed across our sky since is a messenger from that shell, a frozen splinter of the sun's birth, falling inward after millions of years in the dark, carrying the original chemistry of our origins to our doorstep. And because we have never seen it, almost everything about its exact form remains open to argument. Scientists still debate where the inner edge truly begins. They debate the precise shape of that inner hill's cloud. The traditional picture is a donut, but a study as recent as 2025 suggested it might actually twist into a spiral. We are, in a very real sense, drawing the map of a place no eye has ever looked upon, sketching its outline entirely from the trickle of comets it sends us and the cold logic of gravity. But there is one edge we can define, and it is the most important line in this entire story: the outer wall. What, exactly, holds this outer wall in place? Not the sun's wind that died back at the heliopause 1,000 times closer in. What defines the true edge is a battle of gravity. The sun's gravitational pull reaches outward, growing weaker and weaker with distance. But the sun does not pull alone. The entire Milky Way galaxy, its hundreds of billions of stars, its vast clouds of gas, exerts its own gentle collective tug on everything, including the icy bodies out here. And somewhere around 1 to 2 light years from the sun, those two forces meet as equals. Inside that line, the sun wins, and an object orbits our star. Outside it, the galaxy wins. The combined pull of everything else finally overpowers our lone sun. Astronomers call this outer limit the sun's Hill sphere, the true gravitational boundary of the solar system, the farthest point at which our star can still hold on to anything at all. And that boundary is not a solid wall. It leaks. Because the outer Oort cloud is bound so weakly, the smallest outside nudge can tear its objects loose entirely. Passing stars drift by over the ages, and their gravity reaches in and stirs the shell. One star in particular, a small orange dwarf, is predicted to pass within about 10,000 times the Earth-Sun distance in roughly 1 1/3 million years. close enough that it will move right through the outer edge of our Oort Cloud, scattering comets as it goes. And the galaxy's steady tide is always pulling, always reshaping. Some of these disturbances fling icy bodies inward, and we see them as comets. But others do the opposite. They strip objects away from the sun completely, casting them out to drift forever in interstellar space, which leads to something genuinely profound. Over the immense span of deep time, the sun does not simply hold this shell, it trades with the galaxy. It loses icy bodies to the dark, and it very likely captures others that once belonged to passing stars. In fact, some of the material out in the Oort Cloud may have come from the roughly 1,000 sibling stars that were born alongside our sun before that ancient nursery drifted apart, and we have already begun to catch the traffic moving the other way. Objects from other star systems, like the interstellar visitors astronomers have tracked passing through our inner solar system in recent years, wanderers that were flung out of some other star's cloud and drifted across the void to briefly cross ours. The edge of the solar system, it turns out, is not a fence, it is a shoreline where the sun's frozen territory quietly dissolves into the shared ocean of the galaxy. So here it is, the answer we have been chasing since the very beginning. The true edge of the solar system is not Pluto, it is not Neptune, it is not the asteroid belt or the Kuiper Belt, or even the heliopause where the Voyagers crossed into interstellar space. The real boundary is the outer wall of this frozen shell, a sphere reaching 1 to 2 light years in every direction, a significant fraction of the entire distance to the nearest star. Not a cartoon of 8 planets on a page. This, a tiny warm core wrapped in an almost unimaginably vast, dark, frozen sphere, with our whole world buried at its very centre. And what of our farthest travellers, the Voyagers, still whispering to us right now? They will get there, but not soon, and not awake. Voyager 1, moving at over 60,000 kilometers an hour, will not even reach the inner edge of the Oort Cloud for about 300 years, and it will need roughly 30,000 more years just to cross through it and reach the far side. 30,000 years, longer than all of recorded human history, several times over, spent traversing a single shell. But here is the quiet tragedy in that. Long before Voyager reaches even the inner edge, its power will be gone. Its transmitter will fall silent within the next year or two, and after that, it will drift onward as a dead, cold machine. When Voyager finally crosses the true boundary of the solar system in some unimaginable future, it will cross it blind and mute, no longer able to tell us anything about the place it took 30,000 years to traverse. We have never sent anything to this shell, and with the technology we have today, we simply cannot. And yet, Voyager will keep going. Consider what that actually means. One day, billions of years from now, our sun will swell and change, and the Earth as we know it will end. Scorched, transformed, gone. Every trace of the world you are standing on will vanish. But Voyager will still be out there, drifting silently through the dark with its golden record bolted to its side, a message from a civilization on a planet that no longer exists. This frozen shell will still be out there too, quietly circling the aging sun. The sun's realm, in the end, is almost entirely this: darkness, cold, silence, and emptiness, with one small, warm, impossibly precious grain of light and life hidden deep in the middle of it. There is one last thing to sit with, out here at the true edge. This shell, this outer wall, it reaches so far into the dark that it comes a significant fraction of the way to the very next star. The sun's frozen kingdom stretches out until it nearly brushes against the frozen kingdom of another sun. 2 vast spheres of ice, each wrapped around its own star, their outermost edges reaching toward one another across the black, which leaves us standing here at the farthest wall of everything we can call home, with only one question remaining. If the sun's realm reaches this impossibly far, if we have finally truly found the edge, then how far away is that next star? Turn now and face outward, away from the sun, toward the open dark, because the answer to that is the loneliest number in all of astronomy. So you turn, away from the frozen shell we just crossed, away from every mile it took to reach it, and you look outward into the open dark, exactly the way we were told to a moment ago, and waiting out there is a single number, the one astronomers have quietly come to call the loneliest in the entire subject. The nearest star to our own sun carries the name Proxima Centauri. You will never see it without a telescope. It is a dim, cool red dwarf, far too faint for the naked eye. And yet, of every star in this galaxy, this one sits closest to us. Proxima Centauri lies about 4.24 light-years away, a distance of roughly 40 trillion kilometers, close to 25 trillion miles, or, using the very same ruler we built for this whole journey, something like 268,000 astronomical units. Notice what that number actually means. Every distance we have crossed until this moment, Neptune, the Kuiper Belt, Sedna's wild orbit, even the outer wall of the Oort Cloud itself, belonged, one way or another, to the Sun. Proxima Centauri is the first name in this entire story that does not. Proxima does not drift out there alone. It belongs to a family of 3 stars, together known as the Alpha Centauri system. 2 brighter members of that family, Alpha Centauri A and B, circle each other closely, separated by only about 23 times the Earth-Sun distance, slightly farther apart than our own Sun and Uranus. Proxima itself keeps a slow, distant watch on that pair from roughly 13,000 astronomical units out, and a single lap around them takes something close to 550,000 years. In August of 2016, astronomers with the European Southern Observatory announced something that changed how close this whole story suddenly felt. Proxima Centauri, this faint and unremarkable little star, turned out to host a planet. Proxima b is only slightly heavier than our own world, and it circles its dim star so tightly that a single year there lasts just 11 days. Crucially, it sits inside Proxima's habitable zone, the narrow band of distance where temperatures could, in principle, allow liquid water to survive on a surface. But here is the doubt worth naming before you form it yourself. Proxima Centauri is a flare star, its magnetic field considerably stronger than our own sun's, capable of erupting without warning and hurling radiation at anything orbiting nearby. Whether Proxima b could hold onto a real atmosphere under that kind of battering is a genuinely open question, one researchers are still actively arguing over. So yes, an Earth-sized world does sit in the comfortable zone of the very nearest star to our Sun. Whether that makes it livable is something nobody can honestly tell you yet. For a moment, imagine standing on that world anyway, looking up. Proxima itself would hang dim and reddish overhead, fainter than our own Sun looks from Earth, but close beside it, 2 other suns would blaze, Alpha Centauri A and B, each one brighter in that sky than Venus ever appears in ours. 3 suns sharing a single point of view, and from there, the sun that raised every human being who has ever lived would show up as nothing more than a silent, solitary point of light, a bright but ordinary star, lost among thousands of others scattered across an unfamiliar sky. So how quickly could we possibly close a gap like that? Let's test that distance against the fastest machines we have ever built. Take our oldest, most travelled spacecraft, the one that has already been flying without a single stop for nearly 50 years, Point it at Proxima Centauri instead of the empty dark it is currently drifting through, and guess, honestly, how long that crossing might take. Voyager 1 is moving right now at just over 17 kilometers every second, about 62,000 kilometers an hour, close to 39,000 miles an hour. That is fast enough to cross the entire continental United States in under 4 minutes. NASA has actually run this exact calculation. Pointed at Proxima Centauri, at that same steady speed, Voyager 1 would need over 73,000 years to arrive. 73,000 years ago, our species had not yet left the continent it was born on. The migration that eventually populated Europe, Asia, Australia, and the Americas is generally placed somewhere between about 70,000 and 50,000 years ago, meaning every language ever spoken outside Africa, every city, every war, every book sits entirely on the near side of that one number. Voyager's crossing to the nearest star would take longer than the entire span of human presence beyond the continent where our species began. Surely then, our newest machine could shrink that number. NASA's Parker Solar Probe holds the actual speed record for anything human hands have ever built, diving past the Sun at 692,000 kilometers an hour, around 430,000 miles an hour, fast enough to fly from London to New York in under 30 seconds. Point that record-breaking probe at Proxima Centauri, and the number does shrink, just not to anything close to reasonable. The crossing still takes just over 6,600 years. 6,600 years ago, the earliest farming villages of southern Mesopotamia were only just taking root, the first faint experiments in settled life that would, many centuries later, grow into the world's first true cities. Writing itself would not exist for another 2,000 years after that. Our fastest machine, running at the absolute edge of what physics allows, still needs more time to reach the next star than has passed since human beings first began living in permanent settlements. So set the two numbers side by side and let the truth land. Our oldest, slowest spacecraft, 73,000 years. Our newest, fastest machine, built at the very limit of engineering, 6,600 years. Both describe the very same neighbour, the very same 4 light-year gap, the nearest star there is, and notice what neither number contains. Not decades, not centuries, not lifetimes, millennia. And Proxima is the easy case. It is the closest star in the whole galaxy. Every other star system you have ever wondered about sits farther away than this one. Every one harder to reach, every one slower still. If we cannot close this gap, we cannot close any of them. Consider what a number like 73,000 years actually asks of a living crew, should anyone ever attempt that crossing in person. Using an average human generation of about 25 years, that single voyage would span nearly 3,000 generations. People born, raised, and buried entirely inside the same ship, one after another, long before a single descendant ever reached the destination. Not one generation, not 10, not even 100. Nearly 3,000 stacked end to end, spent entirely inside metal walls. No one alive today would live to see it. Neither would their children, nor their children's children, repeated for longer than the whole of recorded civilization, several times over. Consider that comparison directly. The whole of recorded human history, every clay tablet, every king, every war, every book, dating back to the very first writing in Sumer a little over 5,000 years ago, fits inside less than 8% of that single journey. You could fit the entire story of human civilization into that one crossing roughly 14 times over, with room left to spare. Only one proposal on any drawing board today offers even a theoretical way to shrink these numbers into something a human lifetime could hold. That plan is called Breakthrough Starshot, backed by internet entrepreneur Yuri Milner, and advised by scientists including Harvard's Avi Loeb, and the late physicist Freeman Dyson. The idea, strange as it sounds, is not science fiction. Fire an enormous array of ground-based lasers at a fleet of postage stamp-sized spacecraft, each tethered to a sail thinner than a soap bubble. Pushed hard enough, those sails could theoretically reach around 20% of the speed of light, fast enough on paper to cross to the Alpha Centauri system in something close to 20 years, not 70,000. Here is the honest state of that plan, though. Nothing like it has actually been built. The lasers required would be, by a wide margin, the most powerful ever constructed by our species. And even in the best-case version, the tiny craft could not slow down on arrival. They would simply tear through the whole system in a matter of hours, cameras open, before vanishing into the dark on the far side. A serious plan exists. It has never been tested at scale, and it remains, honestly, decades away from its very first real attempt. Set all of that beside the only place a human being has ever actually set foot outside our own planet. The moon sits about 384,000 kilometers away, roughly 239,000 miles, a crossing the Apollo astronauts completed in about 3 days. That is the entire outer limit of human travel in more than 60 years since we first left the ground beneath our feet. Proxima Centauri is not 10 times farther than that gap, not 100 times farther, not even 1,000 times farther. Proxima Centauri sits more than 100 million times farther than the single farthest place any human being has ever physically stood. And this raises a deeper question, one scientists still argue over without ever fully settling it. In 1950, physicist Enrico Fermi is remembered for asking a simple question over lunch with colleagues. If the universe is old enough and large enough to have produced other civilizations, why haven't we found a single trace of one? Decades later, that question still has no agreed answer. Some researchers point to how rare a planet like ours might genuinely be. Others point to how easily advanced civilizations might destroy themselves before ever reaching the stars. But one candidate explanation, among several genuinely competing ideas, is simply the emptiness itself, the same emptiness we have been crossing this entire journey. If every civilization in this galaxy is separated by gaps like the one between us and Proxima Centauri, sending so much as a signal across that distance, let alone a ship, and receiving anything back within a single lifetime, may simply be closer to impossible than anyone likes to admit. Not a filter that destroys civilizations, just a filter that keeps them apart. Step back now, all the way back, and hold the whole shape of it in your mind at once. The planets we grew up memorizing, the vast gulf between the giants, the frozen ring of the Kuiper Belt, the scattered, tilted mystery of Sedna, and whatever unseen thing may be shepherding it, the sun's own breath finally dying out at the heliopause, and beyond all of it, the true wall, the dark, near spherical shell of the Oort Cloud, reaching nearly halfway to the very star we have just measured ourselves against. Every one of those, from the first planet to the outer edge of that shell, belongs to a single, lonely bubble. One bubble, adrift in a black and silent ocean so vast that the nearest other bubble, the nearest other star, still sits more than 4 years away, even travelling at the speed of light. So we can finally return, honestly, to the one question this entire journey was built to answer. Where does the solar system actually end? Not at Neptune, not at Pluto, not even at the heliopause, where our own spacecraft first crossed into interstellar space. The solar system ends out in that frozen outer shell, reaching somewhere between 1 and 2 light years in every direction, a boundary nearly halfway to a star we now know we almost certainly cannot ever reach. Its true scale is not vast because it was built to frighten you. It is only this vast, this empty, this quiet, because that is simply, honestly, what is actually out there. In February of 1990, with its planetary mission already finished, Voyager 1 turned its camera around one final time and looked back the way it had come, from about 6 billion kilometers away, some 3.7 billion miles, well past the orbit of Neptune. In that single frame, Earth appears as less than 1 pixel wide, caught almost by accident inside a stray band of scattered sunlight. Everyone who has ever lived, every war ever fought, every quiet, ordinary afternoon, the entire history of our species, all of it happened on that one speck of light. Carl Sagan, who had spent years pushing for that photograph to be taken at all, later wrote of it simply, "That's here, that's home, that's us. We are a warm, bright island, adrift in an ocean of dark, and knowing exactly how small and exactly how far turns out to be the beginning of wonder, not the end of it. Somewhere, right now, that same tidy poster is still hanging on a classroom wall. The sun and 8 bright planets, close enough to take in with a single glance. It was never true. Not the sizes, not the distances, and certainly not the vast, cold, nearly perfect emptiness the artist had to quietly erase just to make it fit on the page. The solar system was never that neat little row of worlds. It is an almost unimaginably vast, almost perfectly empty ocean of night, with everything we have ever loved gathered onto a single pale grain of light, drifting near its very centre. That is the honest map, finally redrawn, and it was worth every mile it took to draw it. Everything we just crossed, the frozen belts, the wandering dwarf planets, the trillion silent bodies of the Oort Cloud, has been circling the sun for 4.5 billion years without once needing to notice itself. Rock does not wonder how far it has travelled. Ice does not ask what lies past the heliopause. But you do. Out of all that emptiness, a solar system built almost entirely of freezing dark, with barely a rounding error of matter left over for anything else. One grain of it woke up, learned to count light years, learned to miss a star it will never reach, learned to sit alone at night and wonder what's out there. That grain is you. Not small in spite of the emptiness, small because of it, and rare enough, against those odds, to have noticed it at all. Thank you for staying for every mile of it, every planet, every gulf, every frozen shell. If this map meant something to you, a like and a subscribe help more of it find its way back to you. So much of that dark is still unmapped. I'd love to walk it with you. Sleep well tonight. You're still that rare, warm speck the whole universe made room for. Good night.